Our first technique for parametrizing surfaces is to express them as the graph of a function, or solve for one variable in terms of the other two. So what we do is we say, let's find a formula for one of our three variables to make it easily expressible in terms of the other two. And then we're going to set the other two variables to be coordinates. Usually we use s and t coordinates or u and v coordinates so we don't get confused, because it'll get confusing. And then we express all three variables in terms of those parameters. So here's an example. We have the plane 2x plus 3y plus z is equal to 5. That describes a plane. What we can do is we can solve for z. We can move everything over to the other side and say that z is equal to 5 minus 2x minus 3y. This makes z dependent. It depends on x and y, and it makes x and y independent variables. And so I'm going to say, let's give x and y, let's turn them into parameters. Let's say that u is our first parameter and v is our second parameter. I'm going to make x equals u and y equals v. And so when we parameterize, we say x is u, y is v, and then z is this formula, 5 minus 2 times u, because that's what x turned into, minus 3 times v. That's what y turned into. You could instead have just written this. I could say phi of xy is x comma y comma 5 minus 2x minus 3y. That's a perfectly good parametrization too. It's just that there are some times when it's very easy to get confused about which x you're talking about. Am I talking about x in terms of my two-dimensional coordinates, or am I talking about x in terms of my three-dimensional coordinates? And so that's why I want to stick to writing the parameter names as being different. Here's another example of the upper half sphere. So here's x squared plus y squared plus z squared is equal to 1, describes the unit sphere, and then we'll stick to those points where z is greater than or equal to 0. So this describes kind of this half circular cap that lives above the xy plane. For this one, we can solve for z. Because we know that z's positive or 0, we can say that z is equal to the positive square root of 1 minus x squared minus y squared by moving everything over to the other side. Here now, x and y aren't allowed to be arbitrary. X and y are only allowed to be inside the unit circle. And if I then say, okay, well, z is now my dependent variable, and x and y are now my independent parameters, I can find my parameterization by saying x is u, y is v, and z is this formula, 1 minus u squared minus v squared. That gives me a parameterization of this upper half sphere, but I have to say where this parameterization works. This parameterization works only over the unit circle, u squared plus v squared is less than or equal to 1. So we have not only a formula for the parameterization, but we've also got a set of places where that parameterization works.